Everyone thinks a grain elevator is just a big barn. But 5 million bushels sit here, alive, damp, explosive, and 5 steps keep them cool, dry, and from rotting. Here's the problem most people miss. Grain is alive. It breathes, it holds water, and a warm, damp pile will heat itself, grow mold, and rot from the inside. Worse, the fine dust grain throws off is explosive. Elevators are among the most fire-prone industrial sites in the country. Handling millions of bushels safely is real engineering. Step 1. Intake. It all starts below the ground. A truck or rail car backs up and dumps its load into a receiving pit sunk below floor level. A steel grate over the pit catches rocks, corn cobs, and stray junk before they can jam the machinery. From the pit, the grain flows onto a conveyor, or straight into the bottom of the elevator, a spot called the boot. But before any of it moves further, the load gets weighed and sampled. Operators pull a handful and test it for moisture and quality right at the door. Why bother at intake? Because wet grain and dry grain can't share a bin. Grain that comes in at 18% moisture will rot next to grain at 13%. Sorting it now at the entrance decides where every bushel goes for the next 6 months. That raises the obvious question, how do you move all that weight straight up? Step 2. Elevate. This is the machine the whole building is named for. Picture a vertical belt, taller than a 10-story building, running in a loop inside a narrow tower. Bolted to that belt are hundreds of small buckets. At the bottom in the boot, the buckets scoop up grain like a chain of cupped hands. The belt hauls them straight up, 100 feet or more, to the top of the head house, the boxy structure crowning the silos. At the top, each bucket flips over and dumps its load. This machine has a name, the leg. And the leg is the secret to the whole design. A small patch of ground can't spread out, so it goes up instead. By lifting grain 100 feet into the air, the leg lets a tiny footprint stack enormous tonnage, and then feed any bin below it using nothing but gravity. But once the grain reaches the top, how does it know which of dozens of bins to fall into? Step 3. Distribute and store. At the top of the head house sits a clever piece of plumbing. A rotating spout called the distributor swivels to aim the falling grain down a chosen pipe. Pointed at bin 4, and gravity carries the grain down into bin 4. Pointed at bin 12, and it fills bin 12 instead. No pumps, no extra lifting, just a spinning funnel and a long drop. The bins themselves are giants. Concrete or steel cylinders, each holding anywhere from tens of thousands to well over 1 million bushels apiece. And here's why that sorting back at intake mattered. Each bin keeps one kind of grain, this crop, that grade, this moisture level. Mixing them would drag the whole batch down to the quality of the worst kernel in it. Keeping them apart preserves value. So the grain is up, sorted, and stored. But it's still alive, and remember, alive means it can still rot. How do you stop that? Step 4. Condition. This is where rot gets beaten. 2 enemies, 2 defenses. First, water. Grain coming off the field is often too wet to keep. So before or during storage, it runs through a dryer that pulls moisture down to a safe level, roughly 13 to 14% for corn. Below that line, mold simply can't grow. Second, heat. Even dry grain generates warmth as it breathes, and warm spots invite mold and insects. The fix is airflow. Big fans at the base push a steady breeze of outside air up through the entire pile, keeping the whole mass cool and even. This is called aeration, and it's the quiet workhorse of the whole operation. But how do you know it's working, buried under 1 million bushels? Cables. Strings of temperature and moisture sensors hang down through the grain from top to bottom. Operators watch the readings on a screen, and if one section starts creeping warm, they run the fans before a hot spot ever becomes a rotten one. Step 5. Reclaim and ship out. Months later, a buyer calls and the grain has to leave. But it's sitting at the bottom of a bin, not the top. So the flow runs in reverse. Conveyors buried in tunnels under the bin floor catch the grain as it drains out the bottom. When gravity alone can't empty the last of it, a sweep auger, a slow spinning screw, walks around the floor and pushes the leftovers to the outlet. From there, the grain rides those tunnel conveyors back to the leg, gets lifted up all over again, and pours out into a waiting rail car, a river barge, or a truck bound for market. Notice the trick. The same leg and the same conveyors that filled the place now empty it, just running the other direction. 1 machine, 2 jobs. And that's the last of the 5 steps. So how does all of this add up to grain that survives for months? Now the whole machine clicks together. Intake, elevate, distribute, and store, condition, ship. 5 steps, all orbiting one vertical leg. And that design quietly beats the 2 things that destroy stored grain. Fire. Controlled airflow and dust management keep explosive dust from building up. Rot. Drying strips out the water mold needs, and aeration holds the pile cool and even, so no hidden hot spot ever gets started. Meanwhile, the leg does the heavy lifting, literally, letting a small patch of land stack 5 million bushels straight up instead of sprawling across a field. Put it all together and you get the payoff. Millions of bushels held safely for months, cool and dry, then moved out the door the moment the market calls. Not a barns, A living system that breathes on command. Here's what to carry away. Storing grain isn't about keeping it still. It's about keeping it cool and dry while it's still alive. The next time you drive past those concrete towers by the railroad tracks, you're not looking at a warehouse. You're looking at a lungs. Fans breathe air through the pile, sensors take its temperature, and a single belt of buckets moves millions of bushels in and back out. The whole thing is a machine for buying time, turning a perishable crop into something that keeps for months. 5 steps: intake, elevate, store, condition, ship. Keep 5 million bushels cool, dry, and safe. If you want to see how the machines behind everyday life actually work, subscribe and stick around. Next up, how a single spark of that grain dust can level an entire elevator.